Okay, this is chemistry, continuing with our gases unit. So in this lesson, I'd like to show you how to solve the ideal gas law for various things if we know how to rearrange the formula. And the various things I'm talking about will be molar mass and density. So we're going to start this lesson with rearranging for molar mass. And just a little refresher, molar mass was learned when we were studying the periodic table and the parts of the atom. So if you take a look at oxygen over here, this 15.999, that is the mass number for oxygen, which is also referencing the number of grams of oxygen in 1 mole of it. So every element has one of these, and we used that when we were studying the atom. We were calculating this in a small activity that I had for you with these little containers of the elements. And then we also use these in stoichiometry when we're converting between grams to moles using different equations. So you have worked with this before, and I'd like to connect this now to the gases chapter. So we're going to start with molar mass. So again, molar mass is grams per mole. How many grams are in 1 mole? Or you can flip that. 1 mole of a substance has how many grams? So we're going to focus on if you're given mass. So if you have the mass of something in grams, to convert it to mole, you would use the conversion factor of 1 mole per gram. And it looked something like this, right? This is a conversion factor. We did this in stoichiometry. So you have grams, and if you have the grams of a substance to convert it to mole, you would be dividing by that mass that was on the periodic table, because that mass is equal to 1 mole. Okay, so that's where you've seen this. Now what I'd like to do is to start rewording this and rearranging the ideal gas law. So to reword this or to restate this, usually we're trying to go from our words to our formulas, right, or our symbols. But in this case, I'd like to go to the words first. So this G can be called mass. This 1 mole per gram, right, from up here is molar mass. So what are you doing to solve for mole? You're taking the mass and dividing it by molar mass. Now another way of stating this, let's go back to our letters. Mass is M, which you've seen before, but capital M is how we're going to reference molar mass. If you had 2 lowercase m's, then that would look like millimeter and be quite confusing. So it's capital M to represent molar mass. So this is just a restatement of this conversion right here, right? M for grams divided by molar mass. Okay, in the ideal gas law, right, you have N, which is referencing moles, right? And what was this conversion up here? This was a way to solve for mole. So we can replace the N with how to solve it, which is mass over molar mass, or M over capital M, capital M. So we're going to replace N with M over capital M, capital M. Okay, so here's the ideal gas law. And if we substitute N, which is mole, with how to solve for mole, which is mass over molar mass, it would look like this. So now the N is gone, and we've replaced it with how to solve for N, which is mass over molar mass. Okay, so that's one rearrangement. But now, what if I wanted to use this ideal gas law to actually solve for molar mass, or MM? So how can I get this capital M by itself? How can I rearrange this to solve for molar mass? So first it would look like this. MM, you need to get rid of that on the bottom because it's a fraction. So you need to multiply that by each side. So when you multiply it on the right, it's going to cancel. When you multiply it on the left, that's where it's going to move to. So PV, capital M, equals MRT. So I didn't touch this. But now MM is not by itself, so I need to get it by itself with one more step. So how to do that now? MM is now being multiplied by P and V. So to get rid of it, I need to divide. So here is how you would rearrange your ideal gas law to be able to solve for molar mass. So molar mass is equal to M for mass, R is the gas constant, T is temperature, over P for pressure, and V for volume. So let's practice one example now using this. All right, so let's just see what's going on here. So you're being asked to calculate the molar mass of a gas if 35.44 grams of the gas stored in a 7.0 liter tank exerts a pressure of 60.0 atm at a temperature of 35.5 degrees Celsius. You have a lot of information given to you in this problem. So you can use all of this information in one formula, and it's the formula to solve for molar mass. Okay, so this was the original ideal gas law. Okay, but now you're being asked to solve for molar mass. So instead of using this original ideal gas law, remember, we can replace the N with M over molar mass. And you saw how I manipulated all that, or you can go straight to using the equation for molar mass. So if you just want to reference this, that's totally fine. I just wanted you to see why you are using this now. The N got replaced with how to solve for mole, and then we rearranged to solve only for molar mass. So right now you really just need to use this equation to solve the problem, because watch what you're given. Do you have a mass? Sure do. 35.44 grams. T, temperature, right here, 35.5 degrees Celsius. P is pressure, 60.0 atm. V is volume, 7.50 liter. And then the R will be based on this pressure. So you really just need to put in your values here, choose the correct R, and make sure you're using proper units. So again, I'm color coding this to help you see why things are placed the way they are. So, MM, right? That's what we're solving for, molar mass. M is mass, 35.44 grams. That's my orange color. All right, the R was chosen based on the ATM of pressure. So the R that I picked was 0.0821 liter ATM over mole K. So yes, you need all those units because they're going to help you cancel. Look at my temperature though. Why is this 308.5 Kelvin? Because they gave you 35.5 degrees Celsius and you need to add 273. So that's my purple. 60.0 atm is my pressure. It's in red. 7.50 liter is in gray. And then my R value was up here in green. Okay. So now the next thing you need to do is multiply the top. The bottom gets left alone. So I know some of you, again, can just plug this in and solve, but I'm going through this step by step, particularly for the units here. Okay, so when I multiply 35.44 times 0.0821 times 308.5, I get 897.6. The grams did not cancel yet. Liter on the top stays where it is. ATM stays where it is. Mole stays where it is. But notice my K is gone because this K is part of a fraction and it can cancel with the K for my temperature. And now I also multiply the bottom. 60.0 ATM times 7.50 gets me 450. ATM doesn't go anywhere, liter doesn't go anywhere. So I multiplied everything on the top, multiplied everything on the bottom. The next step will be to divide. Okay, so when you divide, it's 1.99. Now, how come I have this gram/mole? Liter cancels, ATM cancels, gram per mole is what I'm left with. And if you need to see some of these cancellations, there's the original. Kelvin is out. Liter and liter cancels. ATM cancels. So what is left? Gram per mole, which is molar mass. So it's grams per